the calculus, differentiation and integration. We have two parts under calculus, differentiation and integration. Okay, let's talk about differentiation. Differentiation gives the slope of any function. The slope or the rate of change of any function. Okay, if you take a straight line, that gives the slope. Okay, so what is the slope definition? Rise by run. Okay, the change in the y-axis by, okay, divided by the change in the move in the x-axis. For example, I'll give you a line equation: 2x plus 3y plus 6 is equal to 0. To find out the slope of this equation, how do you find out the slope of this equation?
I equal to mx plus c.
Yeah, you need to first convert this one into y is equal to mx plus c format. So to convert this one, keep 5y here. Okay, then say okay. So minus 2x minus 6. So then y is equal to be
minus 6 divided
2x by 5 minus 6 by 5. Can we write like that? Okay, so now what is the slope?
Minus 2 by 5.
Minus 2 by 5 is this part is the slope. Okay, minus 2 by 5 is the slope. Because if you compare this one with y is equal to mx plus c, x is already here. So whatever is the coefficient for x is going to be the slope. Minus 2x plus minus 2 by 5 is the slope. What is the y-intercept here in this equation?
Minus 6 by 5.
Minus 6 by 5, because here it is plus c. So plus c is equal to minus 6 by 5. Okay, that is the slope of the line. So let's differentiate it. So this is the equation, right? Y is equal to mx plus c. Differentiate it. To differentiate, the very first formula that we learned previously is, say if y is equal to x to the power of n, then differentiation of this equation, differentiation of y with respect to x, the formula for this one is n into x to the power of n minus 1. Okay, the power of x will be reduced by 1. So that is why here the power is n. The power is n here. So when you differentiate it, the power is reduced by 1. Okay, and the power is also comes as a multiplier here. It also comes as a coefficient. Remember, so this is an equation and we are differentiating with respect to x, not with respect to n, where n here is some constant. Assume it is a constant. Okay, say y is equal to x to the power of 5. What is the differentiation of it? dy by dx is equal to 5x to the power of 4. Okay, so the 5 has come here, x is here, the power is reduced by 1, so 5x to the power of 4. Okay, that's how you need to differentiate it. That is the very first principle, that first formula that you need to learn. Okay, alright, so let's do the differentiation of this equation and we'll see what we get here. So let's do dy by dx. Take the very same equation. What is this equation? This is a line equation.
Yeah.
Straight line equation. Why is it a straight line equation? Because the power of x is 1, the power of y is 1. Okay, if a power of x becomes a square, then it becomes a quadratic equation which represents some sort of curved shape. Parabola, hyperbola, those things. Okay, let's do a differentiation of this one with respect to x. Which gives what is the differentiation?
Minus 2 times minus 2 by 5 times 1
into x to the power of, the power is reduced by 1. That means x to the power of 0. That is 1. Okay, and also the differentiation of any constant is 0 with respect to any variable. Okay, it need not be x, it need not be y, it need not be n, it need not be, with respect to any variable, the differentiation of a constant is 0. Okay, so this is the constant. 6 by 5 is the number, which is a constant, so it is 0. So if you simplify this one, you will get minus 2 by 5. So the dy by dx is equal to minus 2 by 5. dy by dx represents the slope of this equation, slope of this line. Okay, which also represents the rate of change of y with respect to x. Okay, so what is the change in y taking place while you are moving in the x-axis. Okay, what is the change in the y-axis while you're moving in x-axis? Okay, so this is the equation. Say for example, y is equal to 2x to the power of 4. If you differentiate this one, you can keep 2 as it is here. 2 here. So bring this 4 here. X cube. Okay.
Yeah.
This is going to be 8 x cube. Okay. So differentiation of, say for example, y is equal to 5. What is this line? How is this line going to look like?
It is parallel to x.
Parallel to
Parallel
x
to
axis.
X.
Exactly. Yes. Okay. So let's draw this. Let's draw this line. So this is x axis. This is y axis.
C is
So parallel to x axis. So
wait.
this is going to be something like this.
C
this line.
is 5.
Okay. Sorry.
C is 5.
C is 5, and
And slope
also
is
the slope is
0.
0. Slope is 0. By looking at it, you get to know the slope is 0 because there is no change in the y. Y is flat. Y is always 5. There is no change in the y. No matter how you move in x-axis, the y is constant. That means there is no change. That means the slope itself is 0. So let's do differentiation of it. dy by dx. As I said, the differentiation of any constant is 0. So which is 0, which gives the slope. Okay, which is verified. This is the line equation. We draw it here, and by looking at the line, we can easily tell the slope is 0. And when we also differentiate it, we got the answer as 0, which justifies our understanding about the differentiation. Okay, there are few formulas. Let's quickly recollect. Okay, and this also. Say for example, y is equal to k into x to the power of n, where k and n both are constants. Okay, so what is the differentiation of
0 into
differentiation of y?
K times
A times n, yeah,
K
k
times
n x to the power of n minus 1.
minus
Yeah,
1.
you can say that. K times n times x to the power of n minus 1. Okay, so even if there is some constant coefficient here, that constant coefficient will remain as it is. Okay, say that is one thing. And similarly, x is equal to x to the power of n plus x to the power of m. So let's do differentiation of it, this one.
each one.
Or maybe you put some coefficient if you want. Maybe you put a here,
N
maybe put
times
b here. So
Okay.
now you do the differentiation.
B times
B, n are constants. A, B, M, n are constants. The only variable here in this right side is x.
B times N
B times, exactly, yeah, B times n times x
times
power is reduced by 1. Similarly, plus
times
a times m times x power m minus 1. So what I mean to say is whether we have a plus or minus here. This one you can consider as a one function. This one you can consider as another function because this is a function of x. Okay, whole thing is a function of x. But if you want to break it down, this one you can consider as a function of x, and this one is also function of x. If there are two functions separated by plus or minus, the same rule applies here. You can differentiate each part, and then whatever symbol is there, you can keep it there. Whether it is a plus or minus. Now, I'm going to give you another example. Say y is equal to 3x plus 2 multiplied by 2x minus 5. Okay? If you break it down, this is function of x. The whole thing is a function of x. Because the only variable we have is x. You can consider the whole part is a function of x. If you break it down, this is function of x and this is also function of x. There are two functions getting multiplied each other. In such case, to differentiate it, the formula is dy by dx is equal to, first you take this part as it is,
And then
differentiate this part. What do you get if you differentiate? 2x minus 5? 2 plus, okay, plus this one, 2x minus 5, and differentiate the other part, which is 3. Now you simplify it.
6x
6x plus 4,
plus
6x minus 15. So if you simplify, further simplify, minus 11. Okay, so this is the overall differentiation, the differentiation of y dy by dx. That is with respect to multiplication. There are two functions of x which are getting multiplied. In such case, this one as it is, differentiation of this one plus. Remember, there is a plus. Alright, yeah. So let's take another example. So y is equal to, so the same example, instead of multiplication, I'm going to put a division here. Okay, so in such case, so dy by dx, and the formula is you take this part, 3x minus 5, differentiation of this, which is 3. Okay. Okay, these two are getting multiplied, remember. Minus, take this part, differentiation of
2
the denominator 2 by
2x minus 5
whole square.
whole square.
Okay, 2x minus 5 whole square. Okay, the denominator square. Okay, previously denominator is this one, but if you differentiate it, the denominator gets squared up.
So it is
Okay, you simplify it. You know how to simplify it. You simplify it, you'll get the answer. So this is the multiplication of two functions. This is the division of two functions each having x in it. Okay, this you can consider one function having an x, and this one you consider as another function. Okay, let's also take another example. Say y is equal to 3x minus 2 whole square. Let's do differentiation of it. Okay, so the various examples we are seeing here, there is some coefficient here, some constant there. How to differentiate it? There is a function here, function of x. This is also another function of x. There is a plus. Okay, if it is plus, it will be plus, and if it is minus, it will be minus. Here it is a multiplication of two functions. Okay, this is a division. So this one, this is a function, and this function getting whole squared. Okay, so to differentiate this one, you need to consider this whole thing as a sum function, some u or v or whatever. Okay, differentiate that with respect to this function. Okay, so if you consider this whole as one variable, whole thing as one variable, so what is the differentiation? 2 3x minus 2 2 minus 1, that is 1. Okay, and then you do the differentiation of this part, which is 3. Okay, so you simplify this one, 6 3x minus 2. Okay, question can be also be like this. Say for example, under cubed root of.
Oh yes, so
Cubed root of. So how do you solve such thing? Say for example, the same thing and giving it in a different way.
Is it 1 by? No. Wait.
Equal to
How are you going to write it?
3x
3 by.
plus 2 to the power.
Yeah, 3x minus 2 to the power of 1 by 3.
Exactly, yeah. 3x minus 2 whole to the power of 1 by 3. So this is in the same format. You differentiate this one. Consider this as one variable.
Take away.
Yeah, differentiate that one. So 1 by 3. The power comes here. 3x minus 2.
And then
the power will be reduced by 1. That means 1 by 3 minus 1. How much is it?
Equal to
minus 2 by 3.
Oh yeah, 2 by 3.
Okay, minus 2 by 3. And you do a differentiation of it.
3.
Okay. If you want to simplify, 3 gets cancelled, and this is what it is going to be. Okay, say this comes to your mind, like how to, which of these form it belongs to. Okay, this can be written as 3x minus 2 whole to the power of 1 by 3. Powers and exponents, the basics of powers and exponents. Okay. All right. Again, we'll start. Okay, so y is equal to a into k to the power a into x to the power of m, where a and m are constants, belongs to some constants. Yeah, assume that they are constants. Okay, so dy by dx is
A,
a is a constant, m is a
A
constant.
times m times x,
Oh.
x to the power of m minus 1.
Very good. Yeah.
X.
Ax to the power of m minus 1. Okay, so remember the x is at the base here.
And A.
Okay, a is a coefficient. You don't think it as a base or anything like that. A is some constant, some coefficient which is a constant, and m is also some constant. To differentiate it, you got this one. So remember x is at the base. Say I'm going to give it the same thing. A
M.
no a m to the power of x. So I put x instead of here at the base, I put x as a power. Let's do a differentiation of it. dy by dx.
A
times x.
A times m to the power of x. What is the formula for m to the power of x?
Ask
M to the
A root
M
of
to the
X.
power of
x
x.
ln
Exactly. ln m.
ln m.
That's it. Yeah. Okay. So there is a difference. Having a power here at the base and having a power there at the power. There at the exponent. Okay. All right. Let's take a couple of sums from exercise and see whether we can do it or not. Okay, so f of x is also y. Okay, we normally write y is equal to something. So what is y? Y is a function of x. We can also write it as a f of x. Y is a function of x. Okay, square root of x square plus 5x minus 2. Okay, so how do give me some thoughts like how you're going to do it?
Whole to the power of 1 by 2.
Exactly, yeah. Okay, so if that idea comes to your mind, that means half of the sum is over. Okay, so treat whole to the power of 1 by 2. So again, what principle you will apply? That's actually called a chain rule. So you need to consider this whole thing as some variable.
Yeah.
Some variable. So you need to differentiate with respect to that variable, and afterwards you need to differentiate with respect to x.
Yeah.
Okay? Okay, yeah. Okay, keep saying. Okay. What next?
What?
So the differentiation
Expand.
differentiation of f of x by
Differentiation of
with respect to x,
x.
isn't it? So this f of x is y. Differentiation of f of x with respect to x is equal to, so this can be written as whole to the power of 1 by 2.
1 by 2.
So 1 by 2 x square plus 5x plus 2. The power is reduced by 1. How much is going to become?
1
1 by 2?
1 by 2 minus 0. Sorry.
1 by 2 minus 1.
1.
Minus 1 by 2.
Minus 1 by 2.
Minus half. Minus half. And the differentiation of? Now what next?
Differentiation of just x squared plus 5x
Exactly.
minus
Yeah.
2.
So what is the differentiation?
Equal to
It's
2x plus 5. Okay, you simplify it. Simplify it. Okay? Okay. The way you should do is, like say for example, this is differentiation of f of x. Or if you consider this as a y, differentiation of y. Either way is fine. This whole part you can also write it as f dash x. Okay? This convention is also being followed in textbook. Okay, so don't get confused. Differentiation of y with respect to x, differentiation of f of x with respect to x or f dash x. Is that? This is going to be the answer. Okay. Say, what I mean to say, for example, the same thing, consider this whole part as a u. u. Okay, so that is square root of u, whole part under the square root. Okay, so in such case, to differentiate the f of x with respect to x, what you have to do is dy by du into du by dx.
Yeah. And then that.
Okay, differentiation of y with respect to u. If you do this part with respect to u, what do you get? Half u whole to the power of half minus 1. And then what is u? U is this part. Differentiate it with respect to x. This is called chain rule. So du gets cancelled. Yeah, eventually
Chain.
chain rule. Okay, du gets cancelled. Eventually dy by dx will be left out. Hmm? Okay, differentiation of y with respect to u. If you differentiate it with respect to u, what do you get? 1 by 2 u to the power of half minus 1. Isn't it? That is this part. So what do you get? A differentiation of u with respect to x. What is u? This part is u. Differentiated with respect to x. The same thing what we did. Okay. So you consider the whole thing as some variable. We differentiated with respect to that variable. Thereby we got this part, and you differentiate the inner part, inner function. Okay, so there is a line equation given. There is a curved line given. Y is equal to 4th root of 15x plus 1. 15x plus 1. Okay. And there is also tangent touching the point 1 comma 2. There is also tangent. Okay, the shape of the curve is also given, something like this. Okay, let me draw. This is coming up like this, going like this. It's not going exactly like that, but yeah, something like that. Yeah. Okay, that's how the curve. So what is whose equation is this? Whose graph is this one? This one.
This.
Okay. Okay. Is it a straight line? It's not a straight line. Why is it not a straight line? Because the power is not.
Is not 1.
It's not 1. What is the power?
Is it 1 by 4?
1 by 4. Yeah, exactly. 1 by 4. Okay. So that is one part, and secondly, there is also tangent given, and the tangent is cutting this point, is touching this point at 1 comma 2. Somewhere here, there is a tangent drawn. Okay. This point is 1 comma 2. This tangent is cutting this curved line at 1 comma 2. What is the tangent? This is the tangent.
1 comma 2.
Yeah.
This is a
The
tangent.
points.
And the point,
1 comma 2.
yeah, what is tangent by the way? The tangent is something which is touching the curved shape at one point.
Yeah.
Okay, if a line is touching a curved shape at one point, that line is called as a tangent to the given curved line, given curved shape. Okay, the question is, find out to dy by dx at x is equal to 1. dy by dx at x is equal to, find dy by dx at x is equal to 1. You can also write like this, at x is equal to 1. So how do you do that?
dy by dx.
First you find out the dy by dx.
Yeah.
What is the formula for dy by dx? What formula you are going to apply here?
It is
Chain
like
rule.
To find
Yeah,
the slope
chain
of
rule.
the curve, dy by dx.
What curve? Yeah, this is the curve. Yeah, when we are doing dy by dx, that means we are finding the slope of this one.
Yeah.
But how do you find the slope? You need to differentiate this part, this
Differentiate
main
the
equation.
curve equation.
This is the equation which is, yeah, this is the curve equation. You need to differentiate it. So What is the next step?
It is like
Whole to the power of 1 by 4.
Yeah, you can consider this one as 15x plus, sorry, 15x plus 1 whole to the power of 1 by 4. Okay, now you differentiate it with respect to x. What do you get?
1 by 4 times 15.
1 by 4 times 15x
15x plus 1.
whole to the power of, the power is reduced by 1. 1 by 4 minus 1. Tell quickly, minus 3 by 4.
E by
Yeah.
Minus 3 by 4. And is that all?
And just
and
You get a differentiation
15.
of this also.
15.
Okay, you get a 15. Okay. So differentiation of y with respect to x at x is equal to 1. At x is equal to 1. Is the slope constant for this given shape? It is not constant. At every point it is changing. Okay?
So
It is not constant. At x is equal to 1. To find out the value of slope, see, the slope is also a function of x.
Yeah.
That is why it is not constant. If you get some 15, that means it is constant. If you get a 20, it is constant. But here there is no fixed number. It also has x. At x is equal to 1, there will be one slope. X is equal to 2, there will be different slope. X is equal to 2.5, there will be another slope.
Yeah.
Okay, so the question asked is, at x is equal to 1, what is the slope of this one?
Just think
Put x is equal to 1 here. So 1 by 4, 15 into 1, 15 multiplied by 1, 15 plus 1,
plus 1
whole to the power of minus 3 by 4
times 15.
times 15. Okay, how are you going to do that? This is 16 to the power of minus 3 by 4 into 15. How can you write this one? 1 by 4, 16. How you simplify it? 16 to the power of
it is
1 by that way. That is one way. Otherwise, alternately, to even simplify further, 2 to the power of 4. You can write this one as a 2 to the power of 4.
Yeah.
Whole to the power of minus 3 by 4.
And then you
And then
This one gets cancelled
Yeah.
into 15.
times
Okay. This is
So we
minus
just left with
minus
3.
3 power. That means 1 by 2 cube. Isn't it? 1 by 2 cube. 1 by 4 into 1 by 2 cube. It can be write like this. It's actually 2 to the power of minus 3.
Yeah.
2 to the power of minus
Times
3
15.
times 15. So how can we do that? 1 by 4 into
Times
1 by 8
times
into 15.
Yeah, equal to it.
So
15 by
40.
32.
Yeah.
Okay.
15 by 30.
Roughly close to 1.2. 1 by 2, sorry.
So that's the slope of the curve.
That is the slope of the curve at x is equal to 1.
But what's the question?
Okay, that is the one of the question.
The question is to find the slope.
Slope of the curve at x is equal to 1. So dy by dx at x is equal to 1.
So
Okay.
2 then 2.
So is that the answer?
That is the answer. 15 by 32.
Uh,
What is the
so
units for
2
slope?
Equal to.
Nothing.
It's only.
Nothing.
Nothing, exactly. That's a unit less. Why? Because the rise by run. What is the rise? Is a length.
Yeah.
What is the run? Again a length. Length by length?
Gets
Then no
cancelled.
units. It's only ratio. It's only simple ratio. Yeah.
Oh, what's the point of having a line?
I'll tell
A
you. Yeah.
straight
Correct, yeah.
line.
What is the question? Okay.
There's
Find the equation of the tangent to the curve. Find the equation of this
yeah, the line.
tangent.
The line.
And the tangent is cutting at 1, 2. Okay?
Y
At this
equals-
point,
Do
at
we
this
use,
point, this point belongs to this curve and also this
do
straight
we
line.
use the equation y equals mx plus c?
Mx plus c. Yeah, so we need to use that equation y is equal to mx plus c. There are a number of questions in this format. To solve this, you need to understand the concept. Okay? This point belongs to which shape? This shape or this shape?
That is.
Both shape.
Both shapes. It belongs to this particular point, belongs to this line, and this
Oh, yeah,
point belongs to this.
both.
In the straight line, if you know the slope at one point, it is the same slope everywhere.
Yeah.
Okay, it's not a slope something here, it's a different slope here, different slope here. It's not like that.
So you know the slope of
you know the slope of this point.
at
that
that
means
point.
it is the same slope everywhere.
Yeah, and then substitute that in y equals mx plus
Y is
c.
equal to mx plus c. Mx plus c.
Y equals
What is m here?
15 by
M
This is the slope at this point for this curve, and this is the same slope also belongs to this one because that is the point of intersection. So 15 by 32
15 by 32.
into x. What is x? You take this point
1.
1 plus c is equal to y. What is 2? So you'll get a c here. C is equal to 2 minus 15 by 32. You'll get something, okay? Let's say half, 1.5 or something like that. Okay? 1.5 or something like that. So then you put it back here in this equation. Y is equal to 15 by 32 x plus c, whatever c you get here. It could be maybe roughly, I'm giving an approximation 1.5 because this is half here. If you consider this as a half, 2 minus half is 1.5. Okay? Okay, yeah, understanding what is a differentiation, understanding the properties of line, understanding the properties of curved shape is important to solve such problems. Okay, a point is given, a slope is given, isn't it? A point is given on the straight line, and the slope you found out. But the same slope you need to apply for this line also. Okay. Okay, so differentiate this function with respect to x. Say for example, g of x is given like this, is equal to 2x minus 3 by x square minus 4. Okay, I won't do it in detail, but you tell me the procedure. Okay, if you explain the procedure, then that means you know how to do it. So, what rule you are going to apply here?
Yeah.
What formula you are going to apply here?
2, no, like 2x.
Say f of x is equal to a function of u by v. Okay, u is a function of x and v is also a function of x. What is the f dash x?
F
Dash x and what is f dash x? It's a differentiation.
differentiation.
Yeah, what is the
du
formula?
by du.
V
V
du by dx minus u pv by dx by
V no V whole squared.
V squared.
V squared.
okay. So repeat it again. What is the formula in such case?
V
When to apply for first of all this formula?
when there is g of x,
No.
And there is g of x.
or like when
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 u
it's
by
in-
v, like u by v.
in
Some expression
Like a
having x
fraction.
in it. Another
an
divided
algebraic
by another
fraction.
function having x in it. Okay.
X.
It should be function of x. It should be function of x.
Does the
Then only you should
denominator
apply.
does it have to be a squared in the denominator?
It should be function of x. It can be square, it can be
Okay.
cube, or it can be just x.
Oh.
Okay?
Yeah.
Okay, repeat it again 2 times.
V differentiation of
Which
u,
we already explained previously, but still you forgot it, yeah. Do it again, repeat.
V d differentiation of u by differentiation of x minus u differentiation of v by differentiation of x
By?
by v squared.
Again, repeat it again.
V differentiation of u by differentiation of x.
No, it's not like that. Differentiation of u with respect to x. That's how you need to pronounce.
differentiation of u with respect to x minus u differentiation of v with respect to x by v squared.
By v square. Again, one more time.
V times differentiation of u with respect to x minus u times differentiation of v with respect to x by v squared.
The same thing you have to apply here. Okay. Say the same function I'm going to give like this with a slight change. 2x minus 3 by 5. So are you going to apply the same formula here?
Yeah. Oh yeah, it's already slope is there.
Yeah.
Yeah, it's already slope is there.
No, you can't because there's no x in there.
Exactly. There's no x. Of course, even
Like,
if you apply,
There has to be x in both.
even if you apply, you'll get the
Slope
same
is
answer. But there is no need. Yeah, the slope is already
Yeah, slope is already.
already deciphered from this one. Okay, it's no big deal. But even if that idea doesn't come to your mind, you can still do it. Like g of x is equal to 1 by 5 to x minus 3. So any coefficient multiplying this one, you can take it out and do the differentiation of this one. That is enough, which is equal to 2 minus 0. Differentiation of this one
Just
Equal to 2.
is equal to 2. So that is equal to 2 by 5, which is the slope.
Yeah,
2 by
it's the
5.
same.
But what about this one?
This one is a function of x. That's why I said like
Yeah.
this formula you need to apply if a numerator is a
So-
function of x and denominator is also a function of
so-
x. Even for this one, if you apply it, you will get it. How? I'll tell you. What is it dv by dx here? If you apply this one, it becomes 0 because what is v? 5. Whole thing becomes 0.
Yeah.
By v square.
Is 25.
1v is already here. V by v square. 1 by v you'll get. Okay. So what is 1 by v here? 1 by 5. Differentiation of u. What is differentiation of u? 2.
Oh yeah.
Even if you apply this one, but there is no need. Okay,
We
there is no
can
point in making it too
But
complex.
But what? How do you do that one?
This one you have to do it properly using this formula.
Yep.
What is v? X square minus 4. Differentiation of this one is 2 minus 2x minus 3. What is the differentiation of this one? 2x.
Yeah. 2x by.
How you got 2x? Tell me.
2x is the differentiation of v.
Differentiation of v. What is v?
2x minus 3.
No. X squared.
X squared minus 4. But the differentiation of x squared minus 4 is not
What?
2x.
2x. Yeah, that's
It's-
what I put.
It's not 2x.
It's 2x.
And then what's the differentiation of 2x minus 3?
It's 2.
Okay.
By
2
X squared minus 4.
X squared
whole
minus
square.
4 whole square.
whole square. Okay, simplify it. Okay, we'll get the answer. Okay, knowing what formula to apply. When a certain expression is given, when a certain function is given, what formula to apply. Mainly the differential multiplication and the division. This is division. Multiplication I already taught. Find the value of derivative. Okay, derivative or differentiation, both are same. Okay, find the value of derivative h of x something like x to the power of 8 minus 9x to the power of 6 plus minus 5 2x minus 8. Find the derivative of h of x with respect to x at x is equal to 1 or x is equal to 0.
Yeah.
Find the derivative of h of x.
Yeah, so it's
So
same
d h of x by dx. Okay, differentiation of h of x with respect to x
same thing.
or derivative of h of x with respect to x. What formula you are going to apply? At x is equal to 1. At x is equal to 1. Is the question. Chain rule? No, it's not a chain rule. It's a multiplicative rule.
Yeah. I know.
What? Okay. Differentiation.
What is the differentiation here? dy by dx. U is a function of x, second v is a function of x. They're getting multiplied.
So plus d
U dv by dx
Plus
plus
v
v
d
du by dx. Okay, say that, repeat again.
u differentiation of v with respect to x plus v differentiation of u with respect to x.
Correct.
V differentiation of u with respect to x plus u times differentiation of v with respect to x.
Okay. So what is the division formula?
It's the same thing, but it's by.
By
And
and minus.
yeah.
Not only the
For the
minus.
division,
Square
it's
It starts with
and
the
then
v
square.
here. Starts with the v differentiation of u with respect to x minus u differentiation of v with respect to
it's reverse.
x by v square.
It's completely reverse.
Okay, say that again. When u by v. What is the differentiation?
V
Yeah, v differentiation of
differentiation of u
with respect to x
with
minus
respect to x minus
u
differentiation of v with respect to x
by.
by v squared. And there is no v squared here.
There's no v square here. Okay, the same thing. You find it out. So this one multiplied by differentiation of this plus this one multiplied by differentiation of that. We'll get some expression, simplify it, and keep x as 1 at the end. Okay, did you understand? Knowing these formulas are important. Okay, so by multiplying before differentiation, compare your results and check product rule. So f of x is equal to 4 square root of x plus 3 into x square. So what formula you are going to apply? What formula
Oh,
you are going to?
yes, A1.
The same one because
What is the same? What is that?
u times differentiation of
Yeah,
v
exactly.
with respect to x.
So what is the differentiation of this one? Fast, quick, make it quick.
X
2x
sorry
plus
x
square. What is the differentiation of this one? 4 square root of x. What is square root of x differentiation? What is square root of x? Basically x to the power of 1 by 2. So that means half x to the power of minus 1 by 2.
minus 1 by 2.
Yeah.
Or this can also be written as 1 by root x. Do you agree? 1 by root x. Okay, so 4 into 1 by 2 into root x plus
Plus 3, it is 0. Plus 0. Yeah.
okay, here it goes 2 times. So you simplify it. So what is the simplification of this one? Okay. So what is the differentiation? What is the simplification of this one when you simplify? 8 x
8x
root x plus
3. Wait, sorry. 8x root x plus 6x
6x and
plus
Yeah.
x squared. X, yeah, that's x.
how about this one?
Oh, sorry.
How about this one? 2.
Yeah, so 2
So does that mean
by
4
x
squared is 8, right?
What is 4 square?
4 squared.
4. Originally it was 4 divided by 2. So I
Oh, okay.
strike now and put 2 there. So that's the
Yeah, so
answer.
2x squared by root x.
Root x. Yeah. So that's the answer. Okay. So, okay. So also, say for example, if f of x is equal to log x or ln x. Ln x. So what is the differentiation of this one
Same.
with respect to x?
ln
We haven't discussed this one yet. The formula is 1 by x. Remember this.
1 by ln x.
No, 1 by x.
Then what's ln x?
Ln x is a log x with the
Like
e as a
Is that the function? ln x.
ln x is a function of x.
So it's 1 by ln x. That's the answer for this.
No. 1 by x is the answer. Okay.
Is that the
ln x.
formula or
It
is
is
it
the
the
formula.
answer?
It is the formula.
Then what's the answer?
This is the formula, differentiation of f of x with respect to x. If f of x is equal to log x with base e or
Ln x.
ln x.
It's not log x, it's just ln x.
If we differentiate this one, logarithmic function, you will get an answer is 1 by x.
So that's both the answer and the formula for this.
Yeah, this is the formula. This is the formula, okay? This is the formula, remember this one. This is also important. Okay, so a couple of more sums we will do it. Okay, so for example, if f of x is equal to f dash x, so for trigonometric functions also we will discuss. For sin x, it is going to be cos x. Okay, differentiation with respect to x. If it is theta, you should read it as a differentiation with respect to theta. Okay, for cos x, it's going to be minus sin x. For tan x, it's going to be secant square x. Okay, so these are the formulas. Sin x, cos x is, for cos x, it is going to be minus sin x. For tan x, it is going to be secant square x. For example, y is equal to sin theta. What is dy by d theta? Cos theta.
Oh, yeah,
You should tell cos theta.
Cos theta.
Yeah.
Because it's with respect to theta.
With respect to theta. Okay, the formulas here given is with respect to x. But here it is with respect to theta. For example, I'm going to modify it like this. Sin 2 theta.
Cos 2 theta.
Exactly, cos 2 theta. And again, this is the inner function. Chain rule we need to apply. You differentiate this one with respect to theta. So 2 theta, what is the differentiation with respect to theta? It is 2. It is 2.
Yeah.
It's just like
what
2x.
did you say before?
Yeah.
What did you say before?
This is an inner function. Like chain rule you need to apply.
Okay.
For sin theta, it is a cos theta. Because we have 2 theta,
And then
have
you
to
multiply
put
the inner.
Multiply, you do the differentiation of this part with respect to
What's differentiation of 2x?
with 2 theta with respect to theta. What is differentiation of 2 theta? 2. Okay, that is the answer. Okay? Okay, you understand. Okay, so for example, I'm going to give 4th root of cos 2 theta. How can we do that?
So it is 1 by 4.
1 by 4. There are a number of things you need to apply here.
Yeah.
Okay? Whole power
Yeah.
1 by 4, 1 by
First
4, 1 by 4,
And then
cos 2 theta. The power becomes reduced by 1. What is the power earlier? 1. So if you 1 by 4 minus is going to be minus 3 by 4. 1 by 4 minus 1, how can it be 0?
1 minus 1 is 0. So
Yeah, but here it is 1 by 4. The power is 1 by 4. Right. Right now.
Yeah.
Okay. And then that is one part. The second part is what is the differentiation of cos 2 theta? That is one part.
Yeah, and then
Cos 2 theta. What is cos 2 theta?
2.
No. Minus sin 2 theta.
minus sin 2 theta.
Minus a sin 2 theta. Okay, and then what is left? What is left over? 2. And then the differentiation of 2 theta with respect to theta. We'll get a 2. See how crazy it is? Like 3 chains we applied. There is a formula here. Here we applied x to the power of
How
n
did
formula.
you get the 2? Is
Here
it?
2
is it-
theta.
Oh, yeah.
Okay, that's how you need to visualize it. Okay. Okay, this here we applied x to the power of n formula. Here we applied sin theta differentiation. Here we applied 2 theta differentiation. Okay, sin theta is sorry. Here it is cos theta differentiation we applied. What is the formula for cos theta? minus sin theta. Because we have a 2 theta, we put a 2 theta as it is. Okay? Again, explain what we did here.
First, it's
Come
cos 2
here,
theta.
come here and explain.
Um,
Okay, take this one.
it's cos 2 theta whole to the power of 1 by 4. And this, we have it here, and this 1 by 4 minus 1 is minus 3 by 4, and times this sine 2 theta times this 2 theta. That's
Yeah, 2 theta. Differentiation of 2 theta is 2. The cos 2 theta, the differentiation is minus sin 2 theta as per the formula.
Yeah.
Okay. Y is equal to sin theta plus cos theta whole square. What is the differentiation of it? dy by dx. Or, yeah, what is dy by dx? Chain rule? Okay.
Cos theta plus
No, first the whole thing, you
Oh.
consider this as an x. X to the power of n.
2 times.
Don't start with the, differentiating this inner part directly.
2 times.
2 times sin theta plus cos theta power 1. 2 minus 1 is 1. Okay, you don't have to put. And then you start differentiating this one, sin theta.
Sin theta is cos theta
Cos theta
minus sin theta.
minus sin theta. There you go. Okay, so can we simplify this one?
Is sin theta plus cos theta 1?
No, sin square
Sorry.
theta plus cos square theta
Yeah.
is 1. 2, if you differentiate it to say a plus b, a minus b.
Oh yeah.
A
What is-
squared minus b
A
squared.
square minus b
Cos-
square. What is cos square theta minus sin
Okay.
square theta?
Yeah,
This is
equal
the
to.
It's very interesting, isn't it? Like applying what rule to apply when is the key part here. Okay. Again, 2x cos x. F of x is equal to 2x cos x. What is f dash x? F dash x, or a derivative of f of x with respect to x, or a differentiation of f of x with respect to x. Both are all are same. Okay. At various places it is different in various ways, but all are same. F dash x. So what is f dash x here? What rule you are going to apply? Multiplicative rule, because this is a function of x and this is my function of x. These two getting multiplied. So u into, what is the rule? uv.
U.
Oh,
U
D-
differentiation of
v
v with respect to x
plus
v times differentiation of u with respect to
Yeah.
x.
because this is constant, you can take it out. Any constant coefficient you can put it aside. Okay, there is no problem. If you want to apply that multiplicator rule, you can apply this also, but there is no need. Okay, so you can take it out and you consider this as a u and v. So x, differentiation of cos x. What is this? Minus sin x. Okay, put a bracket so that you won't get confused. Okay, it's not x minus sin x, it is x multiplied by this one plus cos x differentiation of
2
no x.
Sorry.
2 we already took
Oh,
it out
yeah.
because this is a constant coefficient.
x differentiation of x
Is 1.
1.
You don't have to put into 1. Okay, 2 minus x sin x
minus sin x squared.
minus no you don't, you should
Like
not do
you
it.
can just think it as
No. You should not do it like that. Okay, this is sin x, this is x. It won't become a sin x square. Okay, you should not multiply this one plus cos x. That's how it is. Okay, so
So
we got
basically you just brought the minus.
exactly, yeah, this is multiplied by this. What does it become? This is plus and minus. Plus
Yeah.
into minus is minus.
Yeah.
X sin x. Okay, sin x into sin x. What is it?
2
Sine x squared.
sine squared x
Sine
squared.
square x. It's not a sine x square.
Sine squared x squared.
No, sine square x. That's it.
Why is it not x squared?
X won't be squared.
Okay.
Okay, just a sine square x.
Okay. Yeah.
Okay. Sine x into x. Then
Sine x squared.
no.
Sorry.
The same thing we have
Sine
here. X into sine x.
Yeah.
That's it. Like
That's
you
it.
cannot multiply this x and this x. Okay. This is within the function. This is outside the function. Okay. Say for example, somebody says f of x into x. What do you say? Is it f of x square? No.
It's not.
X into f of x square. For a better visibility, for a better clarity, you write it this way so that it will be much clearer and clearer.
Yeah.
Okay. Okay. We'll leave it here. There are a number of exercise problems are here. You pick up a white paper and pen and you start solving all the problems. Any questions, ask me, and we'll take another session tomorrow to solve few more exercise problems. All right. Thank you. Have a good day. Bye.